Okay, in this presentation we're going to look at the Poisson distribution, and this is a worked example relating to a motor dealership, or in fact a dealership that specializes in agricultural machinery. So a motor dealership which specializes in agricultural machinery sells on average one vehicle every 2 days. Okay, so answer the following questions. What is the probability that the dealership sells at least one vehicle in one particular day? What is the probability that the dealership sells exactly one vehicle? Okay, so just notice the difference between those two questions there. Okay, so in part A, it's one or more, so we could be talking about one vehicle or two vehicles and so on. Okay, we could be talking about 10 vehicles in one day. But what is the probability that they, sell something? Okay, so what is the probability that the dealership will sell four vehicles or more in a 6 day working week? Okay, so let's say it's open on Saturday. Okay, now just actually, I'm going to emphasize statistical tables in this one, but just actually sort of quick remark that X is the number of vehicles sold. Okay, I'll just actually state that number of sales. Okay, just say what X is and just actually specify what it is. Now, X per day, and XM is our Poisson mean, and that is 0.5. Okay, so just a sort of quick statement like that. When we get to a 6 day working week, we just sort of change it accordingly. Okay, so on average, we expect to sell one vehicle or half a vehicle every 2 days. So our Poisson mean is 0.5. Now, just actually, you might remark that actually I'm using M in this particular video. And in other videos, I might use lambda and mu and stuff like that. Now, I deliberately am not consistent with notation just to sort of keep you on your toes a bit, but just to sort of explain it. After all, it's just a symbol to describe something. Okay. Now, what is the probability that the dealership sells at least one vehicle in one particular day? Okay, so expect number of occurrences per day, m equals 0.5. Now, this is what the question asks us. Probability of x greater than equal to 1. Now, so we're going to look at the tables here, and the tables that I'm going to be using works on the following basis. Okay, probability of x greater than or equal to r. Now, just as a quick remark, Poisson is a discrete random variable. Okay, so that means the probability of x equal to r is not negligible. Okay, so there's a big distinction there between continuous random variables and discrete random variables, and that is very important, particularly when you're dealing with these type of questions. So I'm going to just sort of switch over to my tables here, and this is the Murdoch-Barnes statistical tables. So I'm just flicking through the book here, okay, and it is important to sort of get the hang of these tables, just a sort of bit of practice. Now, some people might be using different type of tables. They may be working on the basis of x less than or equal to r. So you just have to sort of figure out if the values are increasing or are they decreasing. Okay, so that's the key thing. Now, you notice we have, so essentially what I have to go and do here is I have to find where m is equal to 0.5. Okay, so this is the column that I need to work with here. Okay, so let's see if we can blow that up a little bit. Okay, there we go. Okay, hopefully you can see that. Now, I'm just going to get rid of that. So essentially what we're interested in is the probability of, whoops, didn't mean to do that. Pens are tricky. Probability of x greater than equal to 1. Okay, so here we have r is equal to 1. Okay, and this is the column we're looking at. So the answer there is 0.3935. Okay, so that's the answer to the first one. Let's go back to our, yeah, that's it there. Okay, that's the probability of that. That's the answer to the first one. So that's actually all we need. Okay, now, so probability that the dealership will sell exactly one vehicle. Okay, so this is the probability of x equal to 1. Okay. Now, how do we figure that out using statistical tables? So essentially what we have to do is calculate the probability of x greater than or equal to 1, and then from that subtract the probability of x greater than or equal to 2. So just consider the sample points in each case. So the possible values of x when in the first case, x greater than or equal to 1, so that is 1 sale, 2 sales, 3 sales, and so on, all the way up to infinity. It's actually not infinity, but it's essentially there's no defined upper bound. That's a sort of better way of looking at the infinity symbol sometimes in mathematics. It's not defined. And then what we're going to do is subtract these ones here, these sample points, and then we're just left with 1. Okay, so that's the rationale behind what we're doing here. Just looking at the sample points corresponding to both of these. Okay, so we already know that it's 0.3935. Okay, so what we have to do is go back to our tables. Let's look at that. And essentially, it's just actually the value below. So in this case, it's this one here. We just have to go down to the next row here. And there we get 0.0902. Okay, so the answer we're looking for is, I think it's just going to be work out to be approximately 30%. Let's confirm that. Yeah, there we go. That's the answer to the second one, 0.3031. Okay, now just actually as a quick remark, what I could do here is just to rewrite this for the 6-day case. Okay, so in this case, the x will be a Poisson random variable where m is equal to 3 number of sales in a 6-day working week. So we expect to sell 3 vehicles in a 6-day working week. So just a sort of replication of that statement there is what we sort of need. Okay, now I'm not going to do it here. I want to sort of finish up this video here. So probability that the dealership will sell 4 vehicles or more in a 6-day working week. Now really the trick of this question was just stating or recognizing that if we switch from a 1-day basis to a 6-day basis, we have to change the Poisson mean accordingly, and in that case it's m is equal to 3. Okay, so in that case, how does that relate to what we're looking at in our tables? So what we have to do is go down here a little bit and sort of go right to the side here. I just realize I'm right in the corner here. I'm just going to sort of downsize this a little bit. Okay, so it's in shot. So this is m is equal to 3. It's right on the side. And here I have r is equal to 4. Okay, so the answer I get, let's blow that back up and bring it into shot. So I've just unpaused the video there. So the answer works out to be 0.3528. So there we go, 0.3528. That is the answer to the third part there. Okay. So yeah, that's it. That's actually how to use the table. So just a little bit of practice with the Poisson tables. You'll notice here that the probability values are consistently going down. Okay, as you read down the column. Okay, that's an important thing to sort of spot. If you're seeing that they increase as they go down the column, you're looking at a different type of tables which is specified differently, and you just might have to work in reverse. I don't have a copy of tables like that, but they do exist. Alright, let's leave that there.